Welcome everyone, my name is Saurabh and I'm very excited to be here on Edureka Live with you guys. This is the last tutorial in the series, and in the previous two tutorials I've discussed Python code basics as well as machine learning with Python. And during those sessions I've told you to go through some videos, so assuming that guys will move forward. But before that, let me just add one thing. If you have any questions or doubts, please throw it in the comment section. Me and my team will answer them as soon as possible. This tutorial is all about TensorFlow. We'll be learning how to create a deep learning model using TensorFlow, as well as we'll also be looking at various basics of TensorFlow. So let's begin, guys. So this is the agenda. We'll be first discussing what is the difference between machine learning and deep learning. Then we'll see what exactly is deep learning. After that, we'll understand what is TensorFlow, and we'll also be looking at various TensorFlow code basics. Finally, we'll be creating a deep learning model using TensorFlow. So let's begin, guys. We'll first understand the difference between machine learning and deep learning. The most important difference between deep learning and traditional machine learning is its performance as the scale of data increases. When the data is small, deep learning algorithms don't perform that well, guys. And this is because deep learning algorithms need a large amount of data to understand it perfectly. And when I talk about machine learning, the traditional machine learning algorithms, with their handcrafted rules, they will actually prevail in this scenario. Now let's look at the other differences. The deep learning algorithms heavily depend on high-end machines, contrary to traditional machine learning algorithms which can work on low-end machines as well. And this is because the requirements of deep learning algorithm include GPUs, which are an integral part of its working. Deep learning algorithms inherently do a large amount of matrix multiplication operations, and that is the reason they require high-end machines. Let us look at the third difference. In machine learning, most of the applied features need to be identified by an expert, and then it has to be hand-coded. For example, features can be pixel value, shape, texture, position, orientations, things like that. And the performance of most of the machine learning algorithms depend on how accurately the features are identified and extracted. But when I talk about deep learning algorithms try to learn high-level features from data itself. And this is a very distinctive feature, guys. So because of this, this is basically, you can say, a major step ahead of traditional machine learning. Now let's move forward and we'll understand what exactly is deep learning. Now deep learning is inspired from how a human brain works. It is inspired from our brain cells basically, which are called neurons. So multiple artificial neurons are combined together in the form of layers, as you can see in the diagram as well. So these are multiple layers, and the circles that you are seeing, these are nothing but artificial neurons. So here we have 4 layers. Every layer performs some function and send it to the next layer. So the output of one layer is the input to the next layer. So the first layer that you are seeing over here is called the input layer, and the last layer is called the output layer. The last layer that you're seeing here. And the layers between the input and the output layer is known as hidden layer. So here we have basically 2 hidden layers. Alright, so this is how basically deep learning works. Every layer performs some unique function, then the output of that layer becomes the input to the next layer. We have separate tutorial on deep learning, so you can go through that. My team will leave the link in the comment section, so you can just check it out. Alright, so let's move forward, guys. Now basically we use TensorFlow for implementing deep learning models. In TensorFlow, data is represented in the form of tensors. So let's understand that first. So you can think of tensors as an n-dimensional array or list. You can see the 3 diagrams that are there in front of your screen. So the first tensor is basically a tensor of dimension 1. The next tensor is of tensor of dimension 2 because it has rows as well as it has columns. The last example has 3 dimensions because apart from rows and columns, there is one more dimension that is present there. In TensorFlow, the tensors are described by a unit of dimensionality known as rank. Alright, so you can see it in the table as well. So a rank 0 tensor means nothing but a scalar quantity which has only magnitude. When I talk about rank 1, these are vectors. They have magnitude as well as direction. And you can see it in the Python example as well, where it is nothing but a list of numbers. Now again, when I increase the rank, I add one more dimension. Therefore, we have rows as well as columns. So it becomes a matrix. And a matrix is nothing but a tensor of rank 2. Similarly, you can keep on increasing the dimension or the rank, and that's how tensors work, guys. Let's look at various data types of tensors. Now you can see in the table that there are multiple tensor data types. There is integer of 8 bits, integer data type of 8 bits, 32 bits, etc. Similarly, even float type. Then there's even string and boolean type. However, in TensorFlow, you don't need to specify the tensor data type. It will automatically assign the correct type. But if you want to save some memory, if you want to save the reserved memory basically, so I'll explain you with an example. If you require say only 32 bits, then there is no point in reserving 64 bits. So at that time, you need to explicitly mention the data type. So now is the correct time to understand what is TensorFlow. So TensorFlow is an open source software library released in 2015 by Google. Alright, and TensorFlow works by first defining and describing a model in abstract, and then when we are ready, we make it reality in the session. So what does that mean? In TensorFlow, you first define the computations. What are you going to do? Those operations you define, that is nothing but your computational graph. And then you need to run it inside a session to make it a reality. Don't worry guys, I'll tell you session what it is in the next slide. For current understanding, basically TensorFlow, you need to first create a graph and then run it inside a session. So the example that you're seeing in front of your screen, the computational graph, this is what basically a computational graph is. There are certain tensors that pass through this computational graph, and when you run it inside a session, you get the output. All right, so let's move forward and we'll understand the TensorFlow code basics. So TensorFlow programs consist of two sections. The first section is building a computational graph. Here we just describe the computation. It doesn't compute anything. It does not hold any values. It just defines the operations specified in your code. So if your code says multiplication, division, subtraction, everything, whatever computation you have defined in your code, it will just define that. All right, it won't compute anything. It won't hold any values. It will just define the operation. And when you execute it, the output will be just an abstract tensor. So if you don't run it inside a session, just execute it. I'll actually show it to you practically as well. So that when you execute it, it'll just be an abstract tensor. No actual calculation will run. Only operations will be created. Now to actually see the result, we need to run the session. All right. So the session allow you to execute the graph or a part of the graph. Now let me explain this to you with an example. So over here, what we are doing, we are building a computational graph. The first thing we need to do is import TensorFlow as TF, as TD, as TN, whatever you want to do it, that works for you. All right. So we have defined two nodes here, which are constant. All right. And we have initialized them with the values 3 and 4 respectively. Now, when I print node 1 and node 2, it will be just an abstract tensor. It won't give me the values of node 1 and node 2. All right. So in order to get those values, I need to run it inside a session. So I'll actually show you practically with this particular example. So over here, we'll be taking two constant nodes A and B. A is initialized with value 5. Similarly, B is initialized with value 6. After that, we are taking one more node C, which is nothing but the multiplication of A and B. So till now, we have created our computational graph. All right. Next up, we need to launch it inside a session. So once we launch it inside a session, we get the output that is nothing but the multiplication of A and B, which is equal to 30. Now let me open my PyCharm and I'll show you quickly how this works. So this is my PyCharm guys over here. I've already written the code. I'll just explain it to you. So till now, till here, we have actually built a computational graph. All right. So let me just go ahead and print the value of C, and I'll just show you what will be the output if I don't run it inside a session. See, no calculation, nothing has happened here. This is nothing but an abstract tensor that you are getting here. All right. So what I need to do is I need to run it inside a session. Now to run it inside a session, what I need to do is first create a session object. So that I have already done, and my ses object is ses, as you can see it over here. All right. And once you are done with it, you need to run that session. Alright, and I've told you earlier as well that session places the graph operations onto devices such as CPUs or GPUs and provides methods to execute them. That's how session works, guys. Alright, so after that, I'm going to run the session and then finally just close the session. So basically, you need to close it to free up the resources that were used, alright? You can just keep it that way as well, but it's a good practice just to close it. Now just go ahead and run this and you'll see what happened. So this is our abstract tensor and this is what we got after, running it inside a session. Now there's one very cool feature that TensorFlow comes with. I'll explain it to you with the help of the presentation. So I'll just quickly open the presentation once more. Graph visualization. So for visualizing TensorFlow, we use TensorBoard. Now TensorBoard is a suite of web applications for understanding your TensorFlow graphs. All right. So for that, we need to create the object of class for writing summaries, and one such class is file writer. All right. So with the help of that file writer, I'm going to create certain information, or you can say log files that will be used by TensorBoard in order to create the TensorFlow graph. And where I need to create it, where I will create that log file, that I have to mention it here in the path. The path I have to specify it here. All right. And then I'll be creating a graph object. And once you're done with that, open the command line and execute this particular command that is present here. And in localhost and in port 6006, you can actually see your TensorFlow graph as well. Now I'll just quickly open my PyCharm and I'll show you practically how this works. So again, guys, I've already written the code. This is what it is. File is equals to tf.summary.filewriter. Path where I want my log files to be to appear, and then says.graph. All right. So I'll just quickly go ahead and run this. All right, I'll go ahead and there's some problem here. I'll just fix it up. Just a second. File writer, and this is the path where I'm actually going to save that graph, or the log file that will be created, which will be used by TensorBoard to create the TensorFlow graph. And then finally, I'm going to create a graph object. And just one thing, guys, that you need to always remember, that you need to write this file writer command before you launch the session. All right. So just keep this thing in mind and go ahead and run this now. There's some problem with it, guys. I'll just see to it. I'll execute it once more just to see. So here is a graph file that has been created, the log file that has been created, which I was talking about in the beginning. And this is how it looks like, guys. Now what you need to do is open your command line. And over here, move to the working directory. So I'll just go PyCharm projects. And over here, I need to execute this command, TensorBoard -log dir equal to the name of my directory. So just go ahead and click enter. So yep, it says starting TensorBoard at port 6006. Now for that, what I'll do, I'll just quickly open Firefox to show you if this is working or not. Localhost 6006. Go to the graph section. It says it cannot see any graph currently. There must be some problem. I'll just look into that. hyphen log dir. Let's go ahead and see what happens now. All right, fine. So there's some problem, guys. I really apologize for that. And so yeah, this is how it works. And currently there are some issues which I'm not able to figure out what it is. I'm sorry for that. So let's move forward, guys. And till now we have only seen constants. All right. So next up we are going to see what are placeholders, variables, as well as why we need them. So we are going to discuss all those things. So for that, I'm again going to open my presentation. So constants, as the name tells you, that constant, it takes no input and it outputs a value that is stored internally. So once you have defined a constant, you cannot change the values that are present inside that constant. All right. So over here, let me explain you with an example. So we have node 1 with a constant value that is 3 stored in it. Similarly, node 2 is initialized with 4. All right. So these are just the constant values. But what happens when I want my graph to accept the external inputs? That means, what if I want my graph to accept some data that is present externally? So if I want to feed in my model a data set probably, so how will I do that? With the help of constants? Definitely I cannot do it, right? So at that time, what I need is a placeholder. Now placeholders are nothing but a promise to provide a value later. All right, let us understand this with an example. So we have two placeholders A and B. Both are float 32-bit type, and notice that I have not initialized any value. All right, there's one more adder underscore node, which is nothing but the addition of the two nodes. And when I'm running the session, guys, just note here that I'm feeding in the values of A and B. So what is placeholder? Basically a promise to provide a value later. That's what I'm doing when I'm running the session. I'm providing it with values. So you can even feed in a data set over here as well. So that totally depends on your use case. But the question again arises, what if I want to change my parameters? All right. So how to modify the graph if I want new output for the same input? At that time, I need variables. So basically what are variables? As a name tell you, that variables are values that keeps on changing. Excuse me. And when you train a model, basically you use variables to hold and update parameters. Variables are nothing but in-memory buffers containing tensors. And let me tell you guys, you need to explicitly initialize variables, unlike constants and placeholders. So how you do that? Over here, as you can see, I've written this particular line, tf.global variable initializer. So this will basically create an operation to initialize the variable. And when I run it, this will run that operation after launching the model. All right. So once you have launched the model, you need to run this particular operation, and then only your variables will be initialized. So you'll understand all this when we'll create our first model. So basically it will be a linear model. So let us go ahead. For that, I'm going to open my PyCharm once. So this is the code that I have written. Ignore the lines that I have commented right now. Just focus on the things that I've already written here. So over here we have a variable w, and we have initialized it with a value 0.3. Similarly, we have variable b, which we have initialized with a value minus 0.3. After that, we have defined x, a placeholder, which is a float 32 bits. This is nothing but an input that will be feeding in later on. All right. Then we have defined one more node, linear underscore model, which is nothing but the multiplication of w and x, and then add a bias or b to it. Then we have created a session object. After that, we have defined the operations to initialize the variables, and then we have run those and we have run that particular operation to finally initialize all the variables. And then later on, we are running the session. We are executing linear underscore model and feeding in the value of x, which is 1, 2, 3, 4. All right. So when I execute this, they should give me the linear underscore model for each of my input. So as you can see, this is the output, which is absolutely correct. Now, what happens in real world? All right. So at that time, you need to train your model. So basically at that time you have certain set of inputs and you know the outputs for those set of inputs. And you create a model such that whatever output you get through your model is very close to the output that you already know. So basically the error should be very less. So now let me explain that to you with the help of slides. So what happened, you have created a model. Then you calculate the loss. How you calculate the loss? You just compare it with the actual output that you already know. So you have a model output, you compare that with the actual output and you get the loss, all right? And once you get the loss, you need to update the variables. You update the variables, decrease the loss, again update the variables, calculate the loss. If it has decreased, then very good. And if it has reached a minimum value, then just stop it right there. If it is not, then keep on updating the value until the loss becomes minimum. All right. So the basic thing that we need right now in our model is something with which we can calculate the loss. All right, and this is how we are going to calculate the loss. So for y will be a placeholder that will be fed with the output values that we already know. All right, so 0, -1, -2 and -3 will be our desired output, the values that we already know. So this y placeholder will be fed back with these values. And then what we are going to do, we are going to calculate the difference between the model output and the actual output, and then we are going to square it. Once we have squared it, we are going to add all of these and we'll keep it inside loss, and we'll just write reduce underscore sum. That will sum all the squared deltas or all the differences between all the squared differences between linear underscore model and y. So with that, we'll actually get the loss. That is how far apart our model is from the actual output. So for that, I'll open my PyCharm once more, guys. All right, so I'll just quickly remove all of this. Yeah, all right. So this is how we basically are calculating the loss. This is our y, which is a placeholder to which we are going to feed in some values later on in the session, not later on when we are actually, feed in the values. So at that time, I'll be feeding it with some values. And yeah, after that, we are calculating the difference between the actual output and the model output, and then we are going to add all of those values. All right, once you are done with that, you need to create a session object that we have done earlier as well. Then initialize the variables. And when you're running the session, so I'll just calculate the loss here, all right, guys? I'll just type in here loss. And I need to feed in the values of y as well. So these values are 0, -1, -2, -3. All right. So let's go ahead and run this and see what is the loss of our model. So you can see that loss is nothing but is actually 23.65, which is pretty bad, guys. Now, what I'm going to tell you, just pay attention to that. All right, guys. Let me just throw in some multi-line comments. Yeah. Now, notice that our W value that we have initialized is what? 0.3. So let's keep it as 0.3. And the B value that we have decided is nothing but -0.3. Yeah, it is -0.3. Now, if I update these values and I make W value say as 1, and I make the B value as say, oh sorry, I'm going to make W as -1, and B, if it becomes equal to say +1, now let us see what is the output, what will be the error. All right, so our linear underscore model is equal to what? W into X plus B. So we are going to, feed in the values of X, and then we are going to calculate the linear underscore model manually. So this value will be what? When I feed in the first value of X, which is nothing but 1. So when I feed in 1, so the value of W say is -1 into 1 plus the bias value, which is 1. So at that time I get the output as say 0. All right, so which is absolutely correct. I mean, this is equal to the output that I already know. Similarly, I can just go ahead and feed in the other values of x and calculate the linear underscore model. So the next value of x will be minus 1 into 2 plus 1, that is equal to minus 1, right? Which is again absolutely correct. You can see it in the y placeholder, y value that we are feeding in. So this is nothing but the actual output, or you can say the output that we already know. Similarly, I can just go ahead and put the next value of x, which is nothing but 3 plus 1, which is equal to minus 2. And the last value will be minus 1 into 4 plus 1, which is equal to minus 3. Now, 0, minus 1, minus 2, minus 3. 0, minus 1, minus 2, minus 1, minus 2, minus 3. So this is our actual output, all right? And we saw that when I make my variable w as minus 1 and b as 1 instead of 0.3 and minus 0.3 respectively, I get the correct output. I get the output which is absolutely equal to my output that we already know. So my model output will become equal to the actual output. All right. So let us see if that actually happens or not. So it will give me 0 error if that happens. So I'll just update the variable value here. I'll just make it as minus 1 and this as plus 1. So let us go ahead and see what happens. How much is the loss? Okay, I need to keep it in the float type. I'm sorry guys. Yeah, now it will work. So yeah, you can see that we have 0 error here. That means our model output is exactly equal to our actual output. But that happened when I updated my variables from 0.3 to minus 1 and minus 0.3 to 1. But I did that manually. But what if I want my machine to understand that on its own? What if I want my machine to reduce the error on its own? Here I've calculated it manually and it's an easy problem. That's why I was able to do it. But in real world, the problems are not that easy. So we want a machine to learn on its own. So for that, what we have optimizers. Now let us discuss one such optimizer. So we'll be discussing here the gradient descent optimizer. Now let us understand that with an analogy. So suppose you are at the top of the mountain and you are blindfolded and your task is to reach at the bottom. So what you are going to do? You are going to first see where the land tends to descend, right? In that direction, you'll keep on moving. And you need to move on and you need to keep on moving until you reach the bottom. So basically, you need to keep on moving until you reach the minimum error. That's how I'm trying to relate it. So basically, what I'm trying to say is, you won't start moving in the direction that will where the land tends to you will obviously move in the direction where the land tends to descend. That's what my point is, right? So similarly, we want to update our variables in that particular direction where our error is decreasing, right? So if I say change my variable and my error has increased, that doesn't make sense. I have to change my variable in the opposite direction so that error becomes error starts decreasing. All right. The same case is here as well. So we'll keep on updating the variables until we reach the global cost/loss minimum. Until we reach this particular point, we'll keep on updating the variables. And the moment we update the variable more, like if we make more changes to the variable, the error tends to increase. So we need to stop it right there. We need to stop at that global cost/loss minimum. All right. So yeah, you need to first see whether when you're increasing the variable, if the error is increasing, start decreasing it. Similarly, if the error is decreasing when you're increasing the variable, start increasing. So just make sure that your computer reaches the global cost/loss minimum. All right. And let me explain you the math behind it. So the first thing that you need to do is calculate the loss, which is nothing but target minus the output. This is our output that we already know, and this is our model output. The difference between that, square of that for all the values, and then divided by 2. This is how you're going to get the error. All right. Once you've got the error, you need to calculate the rate of change of error with respect to that particular variable. All right. So that you get the change in the weight. Once you've got that, you need to update it. How are you going to update your variable? The new weight is equal to the old weight plus the change in the weight. And again, this process will be implemented. You'll again go back, you'll calculate the error, update the variable, see how much change you need for the variable, and then again you need to update your variable. So this process will keep on repeating until you reach this particular point that I was talking about, global cost/loss minima. All right, and you can simplify this equation as well. Delta Wj, you can place the value of j, and after differentiation you get this particular value. All right, so this is how you actually do it. In our case, we'll define optimizer, which is nothing but we'll be calling gradient descent optimizer with a learning rate of 0.01. So 0.01 learning rate means in steps of 0.01 my variables will be updated. I hope you're getting my point, guys. And then what we are doing, we are trying to minimize that loss that we have calculated earlier. And then later on, we are just going to run the session. Later on, we are just going to initialize our variables. And then I in range 1000 means that it will only go till 1000 epochs. So what I mean by that is only 1000 times my variables will be updated. And we just hope that we reach the minimum loss in that 1000 iteration. And then we are feeding in simply the value of x and y, and then finally ses.run w comma v. That will give me the value of my updated weights as well as bias, or you can say w and b updated values will be given to me. Now I'll quickly open my PyCharm and I'll execute this for you guys. So yeah, I'll just remove this. And I'll remove these comments as well. Yeah. So here I've defined my optimizer with a learning rate of 0.01. Here we are minimizing the loss. Then we are declaring our variable, or initializing our variable. And then this I in range 1000 means 1000 times a cycle will run. That means 1000 times our variables will be updated. Then feed in the values of x and y. X is the input, y is the output that we already know. And then we are going to calculate what is the final value of w and b. That is the updated values of w and b. So when we calculated it manually, for w it came as -1, for b it came as +1. So let's see how good our model is and what will the value of w and b when we run it. So you can see that the value of w is 0.9999969, which is pretty close to -1. Similarly, the value of b is 0.999998082, which is again very close to 1. So manually we saw that value of w should be -1 and value of b should be 1. And when our computer actually performed some learning, the computer also got to know that the value is somewhere around -1 and +1, right? So this is how you basically create a model. Let me just give you a quick recap of how we have done this. First, we have defined our model, what all parameters we require, what we require variables, we require placeholders, some operations on those some operations on those parameters, and then we need to calculate the loss. How we have calculated the loss? We declared a variable y, or sorry, a placeholder y, and in that placeholder we were just feeding in the actual output. All right, that we already know. Then what we did, we optimized the error. How we are optimizing the error? So basically, we are using gradient descent optimizer, in which the weights are updated such that error decreases. And error is nothing but the difference between the linear underscore model, or you can say the model output, and the actual output. Square of that, add all those values, and you get the loss. That loss is reduced with the help of gradient descent optimizer. Then basic stuff, you need to initialize your variables, run the session, calculate the value of w and b, and yup, you are good to go, guys. So let's open slides again and see what we are going to discuss next. So this is our use case, guys. So this use case, what we are going to do is, we are going to feed in our model 3 words, for example, had, general, and our model will create a very unique story for us. Alright, so this is basically an example of a special type of neural network called recurrent neural network, and there's also a special type of recurrent neural network called as long short-term memory networks. I know you guys are not getting anything, so for that you can refer my recurrent neural network tutorial video. I've explained everything in detail along with the code, so you can just go through that. I'm just showing you how powerful neural networks are with this particular use case. So in this use case, what will happen? You'll feed in three words, and it'll create a unique story for you. So basically, how this will happen? First, I've actually already trained this model just to save time. So what we need to do is train a model on some sort of data. So we are training it on a short story which has 112 unique symbols. All right. So what our model will do, it will create a 112 element vector. All right, and whenever I feed in the values, or you can say the words, it will see what is the probability of which element has the more probability of coming next, right? And the vector, the value, whichever word or whichever symbol has the higher probability will be displayed as the output. So this is nothing but I'm trying to depict 112 element vector. And there will be a probability that will be given to each and every unique symbol which is attached to that particular vector. All right, so the value 20 is attached to had, 6 is attached to A, 33 is attached to general. Similarly, even 37 is assigned to council. Similarly, there are 112 values which are assigned to different types of symbols. All right, so when we so basically our model will calculate the probability of what symbol will come next. All right, and once it gets that value, suppose if it finds out that the 37th element has the highest probability, that is, it has 0.6. So the symbol attached to 37th element is council. So council will come next. Again, what will happen? Along with a general and council, these three will become my input, and again my model will predict what word or basically what symbol will come next. So again, the cycle will keep on repeating until it creates a unique story. So guys, I'll just quickly open my PyCharm and I'll show you how it works. Since I've told you that I've already created the model, I've already trained the model. So I'll just type here had a general, because it takes a lot of time, so I cannot do that during the live session. So yep, you can see that it has created a very unique story, had a general counsel to consider what measures the case. You will all, I venture, therefore, to propose that a small bell be procured. And he said that, but at... So yeah, it's pretty unique, guys. I mean, I know it's not, probably you don't find it that impressive, but remember, guys, this story has been created by a machine. All right, so yeah, it's pretty impressive. I find it pretty impressive. So this is it for today's session. I'll quickly open my slides and I'll give you a quick recap of what all things we have discussed. So first we saw the differences between machine learning and deep learning. We discussed 3 differences. Then we understood what exactly is deep learning and how it works. After that, we focused on TensorFlow. We understood what are tensors, how TensorFlow works, and then we focused on various code basics of TensorFlow. We saw what are sessions, how to build a computational graph, and I'm very sorry, guys, TensorBoard could not work today, but there were some issues, and I really apologize for that. So we understood various TensorFlow code basics like constants, placeholders, variables. Then we saw how to create a simple linear model. And then finally, I discussed the use case of TensorFlow, where I was just feeding in 3 values or 3 words, and my model was creating a very unique story for me. All right. So this is it for today's session, guys. And I just wanted to add one thing. Since you guys have attended till the end of the session, so we are giving a good discount to all those people. So for that, you just need to open this particular link, fill in the survey form, and you'll get pretty good discount on all the courses provided by Edureka. So this is our deep learning playlist on YouTube. So you can just go through it. Everything has been discussed from scratch. It starts with what is deep learning, how it evolved, or why are people using deep learning now, what is machine learning, things like that. And then there is TensorFlow tutorial, where I've discussed all the basics of TensorFlow, how to create a model, things like that. Everything is discussed. Then this is artificial neural network. Then introduction to artificial intelligence. So this is a very good conversation video which you can go through, where I've discussed the pretty cool applications of artificial intelligence and its history. Things like that. Then there is recurrent neural network tutorial that I've told you earlier as well. It is a special type of neural network, and yeah, I'm pretty sure you guys will like this tutorial. So just yeah, go on and check it. And yeah, you can check the other videos as well in the playlist. Then we have a Python playlist as well. So if you're new to Python, just go through this Python tutorial videos in this particular playlist, and everything again has been started from scratch. So no need to worry of any prerequisite here, guys. Then if you're looking for live online instructor-led training, you can visit our website www.edureka.co, AI Deep Learning with TensorFlow. So over here, you can enroll for live online instructor-led training. And let me tell you guys, there are some unique benefits that you get with Edureka. First of all, whatever access that you get is for lifetime. Second of all, you always have the flexibility to change your batch, re-attend it multiple times. All those things, all that flexibility is provided by Edureka. And similarly, if you're looking for Python certification training, we provide that as well, where again everything is covered from scratch. We are going to discuss machine learning here as well, and various libraries of Python like NumPy, Pandas, Matplotlib. So all those things will be covered in detail in our Python certification training. So thank you guys. This is it for today's session. Thanks for attending. Have a great day.